Great to have you here. Please, the floor is yours.
Okay, thank you very much.
We hear you and we see you. We see the slides, yes.
Okay. Let me do it this way. So I have a presentation called Climate Models for Policy, A Bridge Too Far. And as you may know about, there was a movie, but a saying that talked about a bridge too far, which means an act whose ambition overreaches its capability, resulting in or potentially leading to difficulty or failure. So a bridge too far is usually something that says, we can't do that. This project is not going to solve the problem. Now, when you're dealing with claims about climate change in this year, you can be extremely frustrated. So we're going to look at a couple of IPCC claims, especially about the models, and see if there is really any evidence for a climate crisis. Now, testing these model claims is something that a dispassionate, objective scientist should do, but being dispassionate and objective is discouraged today. So I want you to look at the IPCC in three pictures. I think these three pictures tell us all that the IPCC wants you to know. On the left is the last 2,000 years of temperature, and it shows a slight decline to about 1800 or so, then a very rapid hockey stick rise. The middle picture shows the temperature of the last 170 years, starting in 1850. And the black is the observations, and if you look carefully, you will see the brown. And the brown are the model simulations, and they look pretty close to what the observations have. But then you see sort of a blue-green color that without carbon dioxide, the models do nothing. They are flat. There's no real variability at all. On the right-hand side, you will see the future out to 2100, where the temperature rises quite dramatically for most of the scenarios. And that is the image, the three images. So if I were to say, what are these three images saying? They would say the following: the climate is worse now than it's ever been, and we know why, greenhouse gases, and it will only get worse in the future. So that's the IPCC boiled down to three images. So let's take them one at a time. I'll concentrate mostly on the second and third ones, but just for the first one, is the climate is worse now than it's ever been. That's what they're saying with this chart of the last 2,000 years made up of proxy data. And Steve McIntyre has already found this to be inappropriate, and I'll just have a slide here to show one of his results. Shows the IPCC version on the left, but if you take those same proxies and use an objective scheme that uses all of the proxies, you get what's on the right. And on the right, you see nothing that looks like a hockey stick shape. So what the IPCC has done is to use an analysis that has a selectively managed statistical method that will automatically produce hockey sticks. You can see many other examples of this in his on his blog. There's a couple of pages there. I hope this presentation will be available to those in the audience so that you can go back and look at some of these slides. So they're trying to tell you that the climate is worse now than it has ever been. But is that true? Well, Lord Kelvin, or William Thomson, made a statement that I like to use a lot that basically says all science is numbers. You have to measure things. You have to determine by numerical methods and so on, by measurement, what is going on with the world. And notice the little red comment there at the bottom, that in the current IPCC, evidence now includes model output and expert judgment. So evidence now is not just the measurements of science, the observations. It is now model output and expert judgment, and expert judgment is able to tell you that your observations might be wrong. So now we've got a confusing thing about what science is. But let's look now at just the comment about, is the weather getting worse? And so the IPCC has this diagram, and it's 3 panels. The top panel, lots of red things for the world that shows temperature, heat waves are increasing. The second panel talks about heavy precipitation and flooding. The third panel about drought. And you see, if you look carefully at the second and third ones, there's really no change that you can attribute to humans. So that it's the top one that has caused the concern, and the IPCC likes to highlight. So we will go and look at that one a little more closely. So this is a picture of the world, and in different units that show North America on the left, South America on the lower left, and Asia, Africa, Australia, lower right. But notice here in the red arrow that these changes are only observed since 1950. Now that means for all of the weather that was quite severe that happened before 1950 is not considered here. So IPCC is very selective in the way they've been able to turn this notion of creating concern if they start in a certain time period. Now, so when you compare any 2 time periods, you're always going to have a change. So the fact there is a change doesn't tell you anything about why that change occurred. Well, let's just look at heat waves in the United States, for example, and go back further than 1850. So if we go back to 1900, for example, we see that in the United States, the heat waves were much worse back in the 30s and even in the 50s and 1910s. And so one could look at that picture and ask the question, have greenhouse gases caused a decline in heat waves in the United States? That would be a normal thing one might ask. But certainly you would not say heat waves have been increasing due to greenhouse gases in a country that has probably the most weather records of any around. And today people like to talk about forest fires and how bad they are, wildfires. If you look at North America over the last 400 years, you'll see this. Oops, okay, there we go. So you ask the question, have there been changes in wildfires? The IPCC says no. I'm getting a little chat here that says, can you read this? I can see that, and I am talking. So the IPCC says weather conditions that promote wildfires have become more probable. But of course, wildfires themselves are not becoming worse, as you can see by the last 400 years here. In fact, it's really just the fact human management has changed things. So you could ask the question, have extra greenhouse gases caused a decline in wildfires in North America? Well, of course they haven't. The decline is due simply to the way we manage forests, but the weather has not caused more, that's for certain. Now, I know quite a bit about wildfires, being from California, and I actually own some property in the area that is wildfire prone. But I want you to look at the blue comment right here on the right, where one of the most thorough studies show that the pre-European burn area for California every year was between 4.5 and 12 million acres. 4.5 and 12 million acres. Well, it turns out that this fire season of 2020 in California that was heralded as the worst ever, turned out to be, as it says down here, under 4.5 million acres, so it did not even reach the average. So wildfires, no, they're not increasing. And I talk about this and other things in a little book I wrote, Is It Getting Hotter in Fresno or Not? It's my hometown, and I show that indeed it has gotten hotter at nighttime temperatures due to urbanization, but not in the daytime. But going back to more thorough examination of wildfires, we find that globally the area burned has been declining because all around the world people have stopped fires when they start because they don't want their stuff to burn up. So in general, IPCC AR6 has low confidence that most extreme events have been changing. If you read the text, it doesn't confirm this point that the world is becoming more extreme. And claiming that the few changes that have been observed are related to human emissions is done with minimal confidence and based mostly on expert judgment. Now, I hope you see that when you read the IPCC, that a lot of the information is based on expert judgment, which means on the opinions of the carefully selected authors of the report. Now, do we know why it has warmed since 1850? Remember that second panel I showed talked about we know why. And so you see this very powerful picture that says, my goodness, that the black line is the observed. And when we put modeled CO2 in there, we get the black line pretty close. And if we don't have CO2 in there, then we just have a very flat line. In other words, if we hadn't put carbon dioxide in the atmosphere, we would have a climate that really didn't have many droughts or floods or heat waves or terrible storms. So that's all the models can do. And I think some of you are probably thinking, but the real climate goes up and down all on its own. And these models have no ability to do that. So let's just talk about what the climate can do on its own. This is the Greenland ice core record showing the last 12,000 years. And what you see is a ragged decline from about 8,000 years ago to the present. And where it says the little ice age right here, you'll notice it's quite cool. And since about 1850, you see this rise in temperature that fits very naturally into all the other ups and downs you see. So what we have here is a climate that naturally goes up and down. But what we saw in that last picture was the models can't do that. They don't have a natural up and down feature to them, so that all they say is that natural variability doesn't count, and all we have is the greenhouse gases that can make the climate change. And all the words I have on this slide describe that. Now, this is a complicated slide, but I think, and I hope you'll be able to get a copy of this presentation so you can look at it later and figure out what's going on here. But let's start with the green box. And this tells us what caused the warming since the last 50 years of the 19th century, that's 1850 to 1900, what caused the temperature change from that time to the last decade, not 2010 to 2019. And so the models, these are all the different models. If you look at the green arrow, you see that the models show no change due to natural variability, which is what we saw in that first slide. No change due to natural variability. So then the models have aerosols. And we see here the models show that you can have anywhere between -1 and 0.1 degree, plus 0.1 degree impact. Well, that's a pretty wide range. In other words, the average is about -0.05 plus or minus 100%. In other words, there's a tremendous amount of uncertainty in this. Then you go to the gray box up here, and this is the greenhouse gas part. And it says the temperature change since 1850 and so on has been between 1 and 2.2 degrees C. Again, a wide range. But if you add the blue and the gray together, you will get the brown, which is the target gray. And so the models figure out what can do with aerosols here, determine what they can do with greenhouse gases here, add these two together, and they get something close to what they are shooting for, the target. And I have an example here of the Hadley Center model. I think this is an interesting example because it says the aerosols had tremendous cooling in the last 100 years or so, but that's too cold. And so they have balanced that by a very hot greenhouse gas in these red circles. And so this red circle up here is the Hadley Center model's greenhouse gas effect, so that when you add them together, you come out with pretty close to the actual target. Now, you might ask, is that real physics? Or is that just tuning the models to the different kinds of impacts they have? And I think you see down here in the red, on the bottom here, it simply says the physics are not known, i.e. the science is not settled, as can be seen by the varying impacts of greenhouse gases. That's this 1 to 2.2. No one knows. Is it 1? Is it 2.2? Is it something else? And aerosols, minus 0.9 to plus 0.1. Well, what is it? And so what you have here is several unknowns about how the climate system worked that are tuned together to come out with a right answer. Physics is not the real of what's going on here. And so, am I being very angry, or am I saying too much about tuning? Well, listen what the Max Planck Model Institute actually wrote in the paper. We have documented how we tuned the MPI ESM 1.2 global climate model to match the instrumental record warming. That says it very plainly. The modelers looked at what the surface temperature did, and they forced their model to agree with that surface temperature, not because of physics, but because of artificial tuning. And so in the brown words here, so let's look at this paragraph here. In other words, the modelers believed that temperature change should produce an ECS of 3K, which is, by the way, warmer than what we have from actual data. The MPI model had originally produced very rapid warming, about 7K. And since several other parameters had already been tuned, the modelers selected to retune the cloud scheme. So they picked the cloud scheme to change and tune so they could reduce the temperature change and produce the ECS value they were guessing was 3K. And so here you have a very clear example admitted by the modelers that their model had things that were wrong in it, and to get the right answer, the right temperature, that target, they just tuned some of the parameters. Physics was not involved. This was an artificial thing to do. So the models are coerced to agree with surface temperature observations. In other words, they are tuned, since the basic physics of their models weren't yielding correct values. So you should be very suspicious about models now. They are doing something they really weren't designed to do if they're applied to policy. So do models tell us the truth about today and the future? And here's the problem, is that how can you determine the influence of extra CO2 on the climate with the difficulty because you're detecting a tiny influence on a massive nonlinear system? The CO2, the extra CO2, is just a tiny influence. So let's look at a simple atmosphere. So let's say the atmosphere is this blue layer up here, and the Earth is the green layer down here. And so if you're standing on the Earth looking up, you will see 100 units of energy coming down. And that's infrared, but if you're looking up, the atmosphere is sending down 100 units from the greenhouse effect. The extra greenhouse gases are less than 1 unit. So when you look at these numbers, 6 by flux, 24 evaporation, 105 by radiation, and so on, how do you know and how can you detect what less than 1 unit might do to a system that has huge numbers that vary all the time? So let's look at this as a tug of war. So the things that cool the surface are the heat flux, the evaporation, the surface radiation I mentioned before. They fluctuate up and down. They don't just stay the same. And those things that heat the surface are the sun and also the greenhouse gas coming down from the atmosphere. What is the extra greenhouse gas effect? It's that. It's a very tiny, tiny bit that has a magnitude that is even less than the amount of variability we have in all of these other things. So that's the hard part of this whole thing, is how do we detect this very tiny extra pull? Well, how do you test the claim that the current global warming is significant and that it is caused almost entirely by a change of 0.5% of one energy flow component, the extra CO2, among numerous larger and more variable components? Well, to test the claim, we must locate a test metric, some kind of measurable response that has the following robust and scientifically defensible characteristics. Okay, it should have a response that all the models have as a dominant characteristic. So if you add the greenhouse gases, all the models show this characteristic. And that response is not there when the extra greenhouse gases are not included. So in other words, your control and your experiment are always different. You always get the same result. And this is important, I think you know by now, the metric cannot have been used to tune and develop the model. And that's what we see a lot of, is we see modelers that tune their models to a surface temperature, and then they say, look, our models agree with the surface temperature, so our models must be right. Well, of course, that's like giving the answers to an examination ahead of time and then being very pleased that your students did well. That's not science. And finally, the observations should come from multiple and independent sources. And so when we did this, Ross McKittrick and I worked on this problem, we found that the atmosphere in the tropics at about 30 to 40,000 feet, or 10 to 12 kilometers high in the tropics, was a very strong metric. That here you see South Pole on the left, North Pole on the right, stratosphere at the top. So this is a cross section of the atmosphere. That all the models have this feature, that when they add the extra greenhouse gas, there was a very strong hot response in the tropical upper troposphere. This happens to be the Canadian model, but all of the models had this. And this is important, this should have happened already. This is from the models for the years 1979 to 2018. So this feature should already have been observed. Now, the model claim, or the hypothesis here, is that significant warming should have already occurred here to change the climate. And we are able to test this claim, which is important. And this is important because temperature changes in the upper tropical troposphere are directly related to global surface temperature changes. It's kind of complicated, but what happens in the tropical upper troposphere is directly related to this feature for the surface temperatures. Now, remember this, all science is numbers, and so we're going to test this claim. Here we have the latest IPCC models and the temperature trends for those models. And the average is about 0.41 degrees centigrade for the period 1979 to 2020. So that's a scientific consensus. In fact, if you look carefully, you will find that many of the hottest models are from English-speaking countries. I don't know why that is, but I guess the English-speaking world likes to think that catastrophe is upon us, and so their models reflect that. Now remember, the modelers did not tune their models to this metric. They tuned their models to the surface temperature, but not to this metric. So this is a real scientific test. What happens when you compare that with reality? You find this, that the observed temperature change during that time was much less, over a factor of 2 less. And so the models fail to tell us what actually has happened in the past. In fact, if you look at the actual diagram, you see in green the observations, and you see the red line, the average of the models. But notice something else. The green line, notice that the observations stay pretty close to the trend. In other words, they don't go very high above or below, which means they have negative feedbacks. And a negative feedback keeps you close to your average trend. If you look at the models, you will see extreme wide variations. On average, a factor of 4 times more variance, more variation than the real world. And that tells you the models do not have the negative feedbacks to temperature the real world does. So Roy Spencer and I are trying to look into this, and here is a simple thing about why the models warm too fast and vary more wildly. When you take an atmospheric column of the globe and warm it up by 1 degree C, we find that models send out 1.4 watts per meter squared, or about 1.4 joules per meter squared. When you do the same thing with the real atmosphere that we measure with our satellite data, that the actual Earth sends out 2.6 watts. So you see the point there is that when the atmosphere warms up, the real world expels twice as much heat as models do. So models retain that heat. They don't allow it to escape through this vent in the tropics that we see in the previous slides. So now you see that it's likely due to greater magnitudes of heat trapping clouds or water vapor. So the models have too much water vapor and high clouds, especially in the tropics, so that they trap the heat, whereas the real world, as you see here, is able to expel that heat. Here is just an example too. Whoops, here we go. Just a little scientific experiment. When you look at 120 years, 1980 to 2100, and you see what the models are showing, this high warming rate for this scenario, a pretty high warming rate here, and the observations are well below. Well, the point here is we are 1/3 of the way through this period here. 1/3 of the way with the observations, 40 years worth. And the models are already very bad. In normal science, you would go back and say, well, there's something wrong with my model. I better look and see how I can fix it. But in today's way of working on climate problems, you just find something wrong with the observations and say your model is right and go from there. Now, the IPCC did say something about this, that the model problems were briefly mentioned, but they really weren't seriously examined. If you look here on the left where the arrow is, you'll see these are trend values. To the right is a higher trend. This is the elevation in the tropics. And you see that the models in red have way too much warming compared to the observations in black. And so this is what I was mentioning before, that the IPCC says, well, the models don't do too well with temperature trends in the atmosphere, but we're not going to talk about that very much. We are very confident that the models are good enough to do for policy, whereas we've just seen they don't have the right energy flow, they don't have the right temperature trends in places like that. So the IPCC AR6 quietly admits there is a problem, but does not address its implications. And so they do say studies continue to find that CMET5 and CMET simulations warm more than observations in the tropical mid and upper troposphere over that period. And that's about it. They don't go into the fact these models are just poor in many, many aspects, and that missing this process, this very important thermodynamic process, tells you the models are not doing well at all. And here's the irony of all this. Even if climate models were perfect, would U.S. carbon dioxide regulations save the planet? And the answer is no. I did this chart for a congressional hearing about 8 or 9 years ago, in which I said, let's make the United States disappear, that the United States cease to exist in 2012. What would happen to the climate? And that is what we have here with the United States. It's red, and without the United States, it's green. So there's no real impact, and that's if you believe the climate models. So the irony here is that even if the climate models were perfect, that if the United States disappeared, it would not make any difference on the planet. So I hope what I've been able to show today is that the message of the IPCC is hard to believe when you look at the information. For they begin with this picture over here, this hockey stick, and say the climate is worse now than it's ever been. But that graph is based on techniques that are artificial, biased techniques I have here, and most extremes are not increasing at all. So no, the climate is not worse now than it's ever been. And we know why, the IPCC says. But this model result is based largely on artificial tuning rather than fundamental physics. And finally, and it will only get worse in the future, models do not reproduce present climate and its energy flows. So because it does not produce the present climate and energy flows, it has little credibility for the future. So that's the 3 IPCC diagrams, the point they try to raise, and I think each one of them can be shown to be not nearly as remarkable as claimed to be. So with that, I say thank you, and I believe that's it. All right, thank you.
Thank you, John. Thanks a lot. So we have a bit of time left for Q&A. Okay, so
Okay, thank you. I think your presentation shows that there's a very fundamental problem in the whole debate. And I guess there will be a lot of observations against your theory from the, let's say, the conventional IPCC people. So is there any discussion going on for the moment? And can you take this seriously? Is this based on the scientific arguments? What is the status of this kind of discussion, which I guess is taking place for the moment?
Okay, thank you. What I find is this, that the climate agenda is so thoroughly represented in the media and in our culture that coming up with a claim that changes the paradigm or the dominant theme just won't get much traction. So what I like to say is, will your claim stand up in court under cross-examination? if you make a claim and you are allowed to be questioned honestly and dispassionately, will that stand up in court? And so what I try to do, and especially with lawyers who are defending cases right now, is really to look at these claims from the IPCC, and you find that there's not much to them. And they do not stand the test of time. They do not stand up to cross-examination and real data analysis that we have here. And I think the one that is easiest to handle is the climate model projections. Those can be shown not to withstand. Now, will the rest of the world understand that? I think they will at some point. I think it will happen through the economic problems that are caused by the policy issues that follow on from climate model use. I think right now we are just seeing the beginning of the fact people are going to question, why are we doing this to our economy? And you're told, well, it's based upon our climate model output and our scary stories about extremes, when once you look at those, that will not stand up to scrutiny. And more people, I think, are going to understand that.
Okay. In your very infamous hockey stick curve, there is one severe mistake that nobody cares about. I'm an electrical engineer, and I do know that the old data of about 500 years and earlier are having a time integration. Basically, they are looked via an electrical low pass with the integration time constant of a few hundred years. The newer data from the last 150 years are taken with a time integration of only 1 year. And now comes the formal mistake. So if you would be an electrical engineer, you would get a clear fail for such an analysis, because if you take 150 years time and get just straight 1 Kelvin increase in time, and now you feed it through this transform process, you do the integration of 200 years, you get only 1/3 of a Kelvin increase. If you do the integration over 300 years, you get only 1/4 of a degree. That means if you would do the right way of Laplace transformation, apply to your signal, then you would find nothing, zero extraordinary increase. It's just in that about 0.25 to about 0.3, nothing else.
Yes, you mentioned just one of the many problems with the proxy data is that earlier you go, the smoother it is, and so you don't have these up and down changes that occur today that we can do with measurements. And so I think it's good to look at some other proxy indicators, like the tree stumps that we find now being exposed that had grown in many of the mountain areas around the world just 1,000 years ago. It was so warm in those areas that forests grew, and then we had a cold period come out. And it's a good point you brought up, is that we are starting our temperature record a lot of times in 1850, 1860, which was near the coldest period in the last 10,000 years. So why wouldn't we have some natural warming? And the models can't do that. They have no way to create natural warming. And that's another one of their problems that needs to be exposed a lot more.
So I have a political question. I think that you are pretty well informed about the political things going on right now. And could you tell us a little bit about the political atmosphere? Do you think there is already a sort of sadness, whether people are rather fed up enough to begin to criticize all this?
That is happening. You know, if you want to get political change, look at what people spend their money on or can't buy. And that is when you really get people's attention. And so when Trump was defeated in the election last November, people were taking photographs of gasoline prices around the country. And it was about $1.70, $1.80 a gallon. Well, now it's close to $3. And so that kind of information, it's called the politics of the gas pump. That kind of political issue is going to be that which changes the climate about what people think about the climate. So I think we're probably thinking the same thing, that the high cost of energy now, which has affected everyone and made life worse, and especially for the poorest among us, they're the ones hit the hardest, that's going to cause a more vigorous look at what in the world this climate noise is about, and can we get a true and real story about a situation with the climate, which I think the evidence is very clear that we are not in a climate crisis.
Okay.
Well, you happen to say that in your hometown in California, the nights had been warmer. Now, I have for some time been saying that the warming of the Earth has been where it is cold and when it is cold. And I don't know if this is really true, but I believe there's something like that. And so I also usually say that the IPCC is doing something that should be impossible. They basically have models that project a better weather, better climate for the Earth, and they have made a large part of the population to believe that it's a threat.
That is a good point. You know, what we say here in the United States is that over the last 100 years, the average American has experienced 4 degrees of warming. Now think about that. The average American has experienced 4 degrees of warming in the last 120 years. Now the reason for that is that people don't like to be cold, so they move south to Texas and Florida and California. That's why the average American is warmer now, because he just moved. He doesn't like cold. So, yeah, what's the problem if we get warmer? That's a good point.
John, I mean, there are a couple of more questions, and we are super running late already. And we have one more. There was somebody in the beginning who rose his hand. And so that's the last one, and then we have to close this session.
That's again a question about the political situation you already mentioned, because it's very important, because all the story you showed us is a cover-up. It's nothing else than a cover-up of the reality. How the Americans react on the theater happened in Glasgow, where 400 private jets came there. Joe Biden gave a speech about the critical climate change, and then he slept, and the Chinese and the Russians doesn't appear there. How the Americans react on this?
Well, Americans are, I should say this, the average American is smarter than you think. That they are able to look at all of the media and find out that most of it is not for them, that the stories about the rich people trying to tell them how to live their lives just doesn't make it. And I happen to believe, even with the Biden administration, they know they want to be reelected. That's their goal, is to be reelected. And you can't be reelected if you make everybody poorer and everyone mad because they're paying more. So I think with all of the talk that you're not going to see much more action on this climate and energy business, because the costs have now gone up so much. People are mad. And that's how political change happens. And we have mad people in the United States paying more for gasoline and food and everything. And so you'll see a change, I think.
Okay, John, thanks a lot. Thanks a lot for having time for us. It was really great, and we hope to have you in person here. Thank you.
Thank you.
Okay, so the next